Hello, so today this section will be about square root of a function. So just to refresh your minds, in 2.1 we looked at radical functions and transformations. So that is when the function is equal to a square root, or we focused more on the square root. And today we will be looking at when the function is under the square root, like so. So let's look at our first example. So we will be looking at the function 4x minus 3, which is a straight line. We will first graph the function and then the square root of the function. Determine invariant points, domain, and range of both functions. So let's just zoom in a bit. So here we go. So I'll graph the function in blue, and then I'll graph the square root of function in red. So this function is just a straight line. The 4 is the slope, and negative 3 is the y-intercept. Okay, so let's write that a little better. Intercept. So we have negative 3, and then it's going to move up and over 4. So here's our straight line. Okay, and we're now going to graph the square root of this function. So remember, f of x basically are the y values from this original function, and we're going to square root all the y values. So let's just draw a table. So all the y values from the original, we will now be square rooting it. So remember, there is a restriction with square root that negative numbers just can't be square rooted. It will be undefined. So we can automatically just kind of eliminate everything from this bottom half because those are negative y values. You just can't square root it. So now let's just put in some points that I'm going to be square rooting. So I'm going to start with just 0. And then 1, and then I'll find, oh, we have a point, let's square root 5, and then we'll square root 9 as well. Okay, so square root of 0 is just 0, square root of 1 is just 1, square root of 5 is 2.236-ish, and square root of 9 is 3. So let's plot those points down. So 0 is 0, 1, 1, 5, where y was equal to 5 is now 2.236-ish, so that's a quarter to my best of abilities, and 9 is down to 3. So before we connect the dots together, I do need to point out one thing. So when you have a value of f of x or y, when it's between 0 and 1, then there's actually something that's a little different. So let's take an example of, if we have the value 0.5 and you square root it, when you square root 0.5, that is going to be, 0.707. You're going to see that in the cases where the f of x is actually between 0 and 1, your square root f of x value is actually larger than before. Whereas when you have values where f of x is bigger than 1, then your square rooted f of x becomes a number that's smaller. So on the graph, between 0, y equals to 0 and y equals to 1, you'll actually need to go over that original graph. I don't know if I zoom in. You're actually going over the line, and then afterwards, then you could kind of connect and go under like so. Okay, let me zoom back out. So you need to go over the line and then under. So then from here, we could just kind of continue, kind of stretching it out to the sides. It'll look something like that. Okay. All right, now let's determine those invariant points. So invariant points, you'll notice, are when y equals to 0 and y equals to 1. It's kind of hard to, I'm just going to draw arrows. Y equals to 0, y equals to 1, These are your invariant points. Okay, just gonna point out where they are, not necessarily the specific coordinates. And next, let's look at the range and the domain and the range. So the domain, let's look at the blue one, domain of the line, well, of the blue graph is just, well, x is going to be, belongs to all real numbers, range y belongs to all real numbers, okay, because keep in mind this graph does continue on forevermore. The red graph, on the other hand, for the domain, well, the domain starts where that original graph has an x-intercept. So maybe we need to calculate that first. So remember to find the x-intercept, that is basically when y equals to 0. So let's just put y equals to 0 into that original equation or original function, 4x minus 3. So when you shuffle things around, you'll have 3 equals to 4x. Divide both sides by 4. So x equals to 3 over 4. That's our x-intercept. So here is basically 3 over 4. And we know that the x values will be anything bigger than that. So our domain is when x is greater or equal to 3 over 4. Range is going to be, well, it can't be negative. That's why I kind of colored it out in yellow, but it's going to be anything bigger than that. So y is just going to be bigger than 0. Okay, on to our next example. So now we're going to graph a parabola and the square root of a parabola, and again determine the domain and range, okay? So with our parabola, looking at our original, thinking back to chapter 1, this first part is our A, this next part is our K. So that means we're looking at a vertical reflection, vertical stretch by factor of 2, and a vertical translation, everything is vertical here, up 8. So to start, I'm going to just figure out where that vertex is, and then I could easily just do the stretch at that point. So remember our mapping here, we have a vertical, so x is not affected at all. We do have negative 2y plus 8, okay? And our vertex typically is at 0, 0, so I just want to figure out where that is. So it's going to be at 0, and it's going to be at 8, okay? So I know that we're going to go 0, and it's going to go up to 8. So at this point, we know that it's a vertical reflection, so our parabola will be upside down, and is stretched by a factor of 2. So instead of 1, 1, it's now going to be 1, 2, and it's going to go down. And instead of 2, 4, is now 2, 8. So 8 is to here. And then instead of 3, 9, we're at 3, 18. That is off the grid. So we're just going to connect these dots. It should be curved, not pointy. And okay, cool. Now we have our parabola. Let's graph the square root of it. So to square root of it, again, we're just going to be doing kind of the similar steps we did before. We're just going to square root the different values, okay? To start, first thing that usually makes it easy, I'm just going to write some steps out here. The first step, when you're figuring out the square root, probably is just to go for the invariant points. Okay, so remember that's at y equals to 0 and 1. So you do know that you have your invariant points there. And then next, you'll just find you know, square rooted points. Okay, just find ones that are easy to square root. I typically like to pick, well, you know, at this point right here, y equals to 4. That's a number that's easy to square root. You could just bring that down to 2. Same with the other side. Where y equals to 4, you could now bring it down to 2. Oops. That point is just not going in. There. Oh, okay. It is just being very, very picky right now. There we go. And another key point is, well, we do know this vertex point will have to be square rooted. So square root of 8 is 2.8-ish. So it's going to be about there. So that point's going to be square rooted down. And now it's just a matter of connecting the points. So 3 connect points. So remember, between y equals to 0 and 1, the line is going to go, the square rooted graph is going to go over. So let's zoom in here. We're going to go over and then under. And then it's going to go over like so. Very, very zoomed in here. All right, let's zoom back out. All right, next we're going to determine the domain and range of both functions. So for my blue graph with the domain, the x values will be all real numbers. It's just going to take, oops. It's going to be, why am I writing it that way? It's going to be x belongs to all real numbers, and the range will be y. Nope, does not belong to all real numbers. Y has this maximum point of 8 and will be anything smaller. So y must be smaller. Oops, wrong color. Y must be smaller or equal to 8. Okay. All right. Next is the red or square rooted graph. Now with the domain, it's gonna be in between this time that that x intercept, and we know here is 2 and here is -2, so x is going to be between -2 and 2, and the range is going to be, well, it goes as high as that square root 8. So it's going to be, and it's not going to go past 0 because it's not going to be negative. So it's going to be between 0 and root 8. Or if you want to write 2 root 2, that is fine with me as well. So you can write that. Or if you wrote 2 root 2, that is okay too. Okay. Okay, next example. So again, we have another parabola, but this time this parabola is going to look slightly different. It's just going to have a vertical translation up 4. There's only one translation, so I'm going to write it there. So it's a normal parabola that is just kind of up here. Okay. And now we're going to square root it. So this time, here we don't have any invariant points. So we're just going to skip to the second point and just square root points now. Now we know the 4 is going to go down to 2. And let's see if there's any other points now. So here is like 9-ish. So that's going to go basically down to 3. Oops. 3. I don't know why I'm so picky with the pen today. 3. Yeah. Okay. And now we're just going to kind of connect them and draw it best I can. So we do know with the parabola that the points kind of go higher at a higher and higher. So it's gonna actually curve up pretty quickly too. So it's gonna probably look something like that. Okay. So let's look at our domain and range again for both of these. So in our blue graph, our domain will again be x belongs to all real numbers. And the range this time starts at 4 and goes above. So y must be greater or equal to 4. With the red graph, well, since everything, the domain is going to remain the same. It's going to be all real numbers. The range, though, in this case, well, we square rooted it, the number, so it's going to be starting at 2, and then it'll be anything bigger than that. So y will be greater or equal to 2. And that's it for this function. All right. Last example here. So yes, we are graphing another parabola again. So again, just gonna same deal. Blue, red. Okay, let's go. So here we have A and okay, again. So we have a parabola that is at, it's going to be starting at -2. And it's going to go open upward and have a vertical compression of half. I'm not going to write out all these transformations now, okay? So instead of 1, 1, or moving up 1, 1, we're kind of going half instead. Instead of 2, 4, it's going to be just up 2. And then 3, 9 is basically going to be at 4.5. Oh. And then instead of 4, 16, we're just going to move on to 8. There's 5, 6, 7, 8. And I think I have enough points to make my parabola. So it's a slightly expanded parabola. Haha, so there's our parabola. So now it's a matter of square rooting the points. Step 1, invariant points. 0 and at 1. When y equals to 0 at 1, we have invariant points. Next, let's find other key points. So where it's at 4, if you go straight down, is now going to be 2. Where it was 9, comes straight down, we're at 3-ish. 4 comes down to 2. 9 comes down to 3. Okay. And now it's just connecting the dots. Remember, between 0 and 1, go over. And then after that, then you could go under. Ooh, shaky, shaky, shaky. So it's going to look something like that. And again, it's going to go over and under. And it's going to go out like that. Okay? So this graph is a little different, but the strategy to complete it is exactly the same. All right, domain and range time. Domain is, in this case, again, is x are all real numbers. Range. Well, at this case, we do have a minimum, so it's going to be starting from there. So y must be bigger or equal to -2. Okay. Next, for the red graph. Again, the domain here can't, well, it starts at the x-intercepts. So here's 2, here's -2. So domain will have to be either x is less than -2 or x is greater than 2. And then the range, since there's no negative numbers, and we do have an x-intercept, so y will just be greater or equal to 0. Okay. All right, so let's just kind of summarize our findings here. So we have this little table that will help kind of with some of the values. So when we have an original function and f of x is smaller than 0, then when you have the square root f of x, what does that mean? Well, it's undefined, or it just does not exist. So let's just write that down. At this point, it does not exist. Okay. Now, when f of x is equal to 0, then on the square root graph, the f of x and the square root f of x will intersect. They're at the same point. That's one of our invariant points. Okay. When f of x is between 0 and 1, then the location of the square root graph will be above. So those are the times when I try to zoom in to show you that the square root f of x graph is above. So square root f of x is above the f of x graph. And when f of x is equal to 1, then again, we're at another invariant point. So f of x and root f of x will intersect. And last but not least, when f of x is greater than 1, then those locations of square root f of x will be below your f of x. So the square root f of x is below f of x. Okay? And that is the end of this section.